everybody, welcome to Season 3 of Spooky Action at a Distance television show. I'm your host, Kyle Finley, and this is the best show north, south, east, and west of the Rockies. And today we're going to be having a repeat guest back. You know, he's been all around the world doing TV shows and about everything in the world. And he's a repeat guest. We love having him on here. Dave, how you doing today?
Good, Kyle.
Just good?
Excellent. I
mean, you've been doing, you know, we just got back, the AIAA big conference, right? You know, so really got your paper out there and everything, and you're just doing good?
Our first published paper, that's correct.
First published paper? Yeah.
On space warp.
But I mean, yeah, really, you've been on, you know, Discovery Channel, History Channel.
Learning Channel, Nat Geo. But most of all that has been about Bermuda Triangle. And my relationship to it is from an environmental point of view of explaining how thunderstorms rapidly develop in those regions and why that would take down aircraft and disrupt shipping, you know, rogue wave activity and that. I don't take it from a pseudoscience point of view. I'm looking at it more from an atmospheric hard science point of view.
Yeah. And we have previous shows, if anybody wants to check those out, you know, covering the Bermuda Triangle and also covering space warp. You know, we've talked about this a lot before, but
Sure.
This show is just going to be a continuation on that, more of the, just at the experiments and then, you know, some of the newer stuff that's been happening, you know.
Well, it was more of a relationship to the shows that I did with the Bermuda Triangle that posed the question, how did Bruce Gernon and other pilots have a linear displacement? And
it was time warp, right?
Well, they believed that they had gone, well, at least one of the pilots believed that they had gone through what would be representative of a time warp, but there's absolutely no evidence of that. And the real evidence in linear displacement is more due to a natural phenomena of a non-sustainable local space warp bubble.
Okay.
And that's generated as a result of these, what I refer to as mega thunderstorm activities. Now we've had these types of scenarios from World War II to present day. And I have gotten documents along the way from a lot of these pilots' testimonies. And many people in the scientific community will consider this to be pretty much anecdotal. However, each pilot has a similar story in the way that they got displaced and everything leading up to that. So if that wasn't true, then if we took this thing into the laboratory to simulate this and to simulate a thunderstorm activity or the electric fields generated from thunderstorms, then we would dispose it, right? The pilots would not have had accurate observations. Yeah,
if you can't replicate the experiment in the lab, then it's like you just throw the stories out, right?
And that was really the key. I mean, for 14 years I had researched and, you know, had actually interviewed pilots and got testimonies together, looked at the weather forensics for each one of the cases. I looked at like out of 56 cases of pilot losses off the coast of Miami, in the Bermuda Triangle, quote, which you could put a square or parallelogram.
Yeah.
Triangle makes it sound mysterious, and that was just represented by a newspaper guy.
But some of the newer stuff now is we want to talk about the AIAA conference, right? Because now your paper is going to be published. You're a made man, right? You can walk all over people now. You're like, got a paper
got a published paper. Credibility is way high now.
So how about we talk about the conference a little bit, you know, what happened there, how did it go, and your reception of it?
Sure. Well, I was pretty hesitant about the reception that we would get at the AIA, and that's the American Institute of Aeronautics and Astronautics. And it was held this year in Cincinnati. It was on July 10th. Our paper would be given on the 10th of July. It was a Tuesday in the morning. And so we drove 12 hours, got there.
Beautiful scenery, right?
Beautiful.
You loved it the entire way.
Flat corn, you know. It was uneventful as far as the topography of the trip. But anyway, but when we got there, really exhausted, got up, checked in, got the briefing, loaded up our PowerPoints and stuff. But what was interesting, about 10 minutes before we gave our paper, the room that we were in, and it could seat like 160 plus people. Oh, there was probably 25, 30 people in the room. And then suddenly about 10 minutes before, the room started to pile up with people, fill up. And then at last count, we had somewhere about 180 people. And as we were told later on after the paper was given, that over the last 3 days of the conference, that was like the largest room gathering of people. Mm-hmm. So obviously there was a lot of interest in a local spaceport bubble being generated by a variable electromagnetic drive. And the difference of the kind of hardware, excuse me, the difference in the kind of hardware that we use versus what's out there in space right now, majority of the equipment is ion drive, which means they have a xenon-based propellant. They ionize it or electrically charge it, and then it's emitted through the rear end of the thruster.
So they're still fuel consumption engines, basically.
Yeah, but it's highly efficient. It's not a chemical, but it's electrified. Now they build up acceleration over time, and like for example, Project Horizon, which went to Pluto, took 10 years to get there, and the average speed of the engine was approximately 50,000 miles an hour, but it took 10 years to go 3.8 billion miles. Mm-hmm. So, and that would be about 5.5 hours light speed. So space right now for humans to explore is fairly inefficient unless you're going to the moon. But anything outside of the moon for 3.5 days would be months. So to go to Mars, over 10 months to get there.
And that's just one way, you know, there's no coming back.
And well, the coming back is you have to manufacture your own fuel and separate water that's on Mars and separate it into hydrogen and oxygen. But the advantage of the discovery that we made that the warp bubbles can be created naturally between thunderstorms. So essentially, we have two fields being generated on two thunderstorms side by side.
And we got a picture of this, I think, number 12, if we get that brought up.
Sure.
Continue.
Yeah. And if we put another thunderstorm up to either side of it, the electric field that's generated is what they refer to as a tripole field. And in other words, it's a dipole over an inverted dipole. So plus, minus, minus, plus, and the minuses are into the freezing level of the cloud. And the interesting aspect of this is that it really doesn't make a whole lot of difference where you are in the world. Yes, there was a pilot that experienced this in the Bermuda Triangle. There's also another pilot that experienced from Alaska to Japan, another one in northern England, northern London, I should say, and another one from Kwajalein to Guam. So in all areas around the world, if the conditions are right, you can get these anomalies. Mm-hmm. They're not sustainable, but when they hit, you can get displaced hundreds of miles. And in one case, as far as 300 miles downrange.
Sure it's not just a tailwind blowing these guys?
At the conference, we did have one individual that tried to stress the fact that tailwinds at 319 miles an hour were the reason why the pilot went from point A to B, but that's basically impossible to do, not at 5,000 feet in altitude. And the Bermuda area are high altitude tailwinds. They're not experienced into the lower levels. Plus, this pilot made numerous amounts of different turns and angles and everything else. He would have had to gone 319 miles an hour from point A to B, which was 260 miles from Andros Island to West Palm Beach.
So it's totally impossible, basically.
It is, yes, impossible. So, but after interviewing that particular pilot and flying with him in a couple of these programs we had done with Nat Geo and also History Channel, began to realize is that there has to be an explanation. It's not time travel. And then I came across some articles by Miguel Alcubierre. In 1994, he came up with a theory about traveling in space and utilizing warp bubbles, space warp bubbles.
Got a picture for that, Spacetime too, number 1.
Sure. And there we go. And basically, his proposal, his theory was that if you have enough energy to create a collapse, in other words, mass can create a space-time metric, which means a compression of the fabric of space. Einstein in just general relativity talks about that with massive objects, say like a black hole, the sun, the earth. All of that produces what we refer to as a compression of the fabric of space. And that's been proven with the Gravity Probe B experiments. So we do have frame dragging around the Earth. It can be verified and proved with the LEGO satellite and a bunch of other different instrumentation. It's been a long time in coming, but to develop this equipment takes time to do and invent it and then also have it available. It's very expensive stuff to work with.
And you can afford all of it, right? You can
well, that's why
cash out, dumping out of your pocket. All these TV shows, right? They've been paying you.
I teach 5 different colleges, and that's the only reason why I can afford to do this. And it's a lot of work, but the work is very gratifying in the sense that we've been able to reproduce what pilots had as an anomaly flying into these thunderstorms and getting displaced in a linear projection downrange. We've been able to actually do this, replicate it in the lab. So now we can create artificial, in comparison to macro spaceport bubbles from thunderstorms, we can create micro or miniature spaceport bubbles.
And that's exactly what you did, right? And we have number 2 for an experiment where you kind of replicated a thunderstorm.
Well, that's actually one of our devices.
Model 16.
That's Model 16, our latest engine that we've created that literally will artificially induce a warp bubble. But if we were to put up the other image.
Yeah, we should have one in there, number 2. If you'll get around to it anyways.
Well, and so our basic experiments, as we brought those into the...
That's the one.
Right. We developed a tripoled antenna set with an interferometer and a laser. And what we did was we, using the interferometer, we directed a laser beam, split the beam, so then we could have the laser beam as a sensitive agent, so to speak, between the antennas. And we activated them with an RF energy, 25 to 100 watts of power. And then we got these fringe patterns up on the projection screen. And what it began to tell us is when we turned the system off, the laser on the projection screen bloomed out. When we turned the system on, the laser compressed. And that was the beginning of the exploration that we have been doing over the last 5 years of developing the experiments. That was the first indicator that we were getting something.
Yeah, and something other than, random interference.
Well, you shouldn't be able to do that through RF
Another
energy.
case of an impossible thing happening.
Yes.
And so you kind of link that up with the Bermuda Triangle.
And since we were paralleling thunderstorm activity, this kind of hit home in that aspect that we were getting some kind of a result. But the next thing in the space warp metric, which you have to look for in this compression of the fabric of space, just using energy, and that's what we're doing here instead of mass, but they're all correlated. So in general relativity, mass or energy are equal. So this was the good stuff of just being able to generate energy and being able to manipulate the fabric of space. But we would have to then have experiments that then verified a redshift and then also being able to go through solid objects. If we were actually altering the fabric of space, then we should be able to alter objects on an other side of a solid object.
Yeah, and that would set you aside from any other propulsion type technology that pushes it. This is actually a pulling engine. It doesn't thrust, it pulls into the V-shaped cavity of the motor. And we also have some magnetic flux and gravity data that shows the actual ascending into the motor and then up and out expanding. Because Alcubierre's theory was basically you compress the front part of the spacecraft in compressing the fabric of space,
And as it goes up and over the craft, it then expands back to normal space, and it's basically a bubble within normal space, but it all pushes forward in that capacity. So the fact that pilots actually did this was a clue, and whether anybody wants to consider it true or not, we didn't care, because if you can verify it in the, if you can verify it into the laboratory, well then you got it. And if you can actually demonstrate movement. Now,
so then our number 4, we have a Cavendish experiment picture on there. You want to talk more about that?
Sure.
Kind of glanced over it a little bit, but this
well,
is
the redshift that we got was actually frequency change into the motor. So our exciter transmit at a VHF frequency, and what we did was we measured the actual frequency going into the motor, and it was pushing in. In other words, the frequencies were being depressed. So that's a redshift going away, in this case going into the motor. Now, this particular experiment went through solid object. Now, this is a Model 13 version. The newer ones are like 2 foot in length and 6-inch deep. But
I think we have on there.
This was a lower powered unit. But
yeah, number 7, right?
In this picture, we have the motor up near the solid case here. And it's a torsion bar. In this case, we have non-ferrous material there, weighs about 1.5 pounds, and it's on a torsion bar that's perfectly balanced out. And the motor, up to 140 centimeters away from the solid object of glass and wood, pulled the material on the torsion bar, suspended with a monofilament line, and it actually moved towards the motor, verifying the fact of compression of a laser beam, redshift into the motor, and then now actually activating the fabric of space in such a way that it goes right through solid material. And at that juncture, then we began to make measurements of the pulling factors of the motor. And that's probably the most exciting part about the whole project, is that we have gotten up to 1.5 pounds of pull from the motor. That's been, again, we calibrate it every time. We have, we've done the experiments hundreds and hundreds of times. And we've verified with graphs and everything of the pulling nature of the motor, newtons against the, how many watts of power. And the interesting piece about it is that at 1,650 watts of power, we were actually able to pull 1.5 pounds.
What's 650 watts comparable to? You know, like we throw a lot of that value out there.
100 watt light bulb. Old time 100 watt light bulbs of like 10, 15 years ago.
Not the new fluorescent ones.
You can't get those anymore. But if we were to put 6 of them in a line and another 50 watt light bulb, there you go. That's the equivalent of power. It's not that much.
Yeah. What's a microwave use, just for reference?
They're into, well, the frequency is 1.2 gigs, and from a wattage standpoint, it's like 1,200, 1,400 watts.
Okay, so that's like about twice as much as that you've used in recent
correct.
Experiments.
Yes.
Okay.
And you know, you can cook your turkey and everything else in there.
Cook your turkey and create a couple space warp bubbles at the same time,
you can create
right?
plasma in the microwave if you want. But the bottom line, though, was that everything that we've done has verified the fact that we are getting the type of results that you would expect to see. Now, in addition to that, what we did was we took another sensor pack, put it into the Faraday cage, which we keep the motor in, and we address all the experiments there. We haven't really detected any kind of radiation from the thing at all. It's been equivalent to what the background radiation is normally in the environment. So there's no worry there.
But you did get magnetic and gravitational data.
And so with the sensors that we used, and we were using our Raspberry Pi little computer thing to
I love
collect the
Raspberry
data.
Pi. You can eat that up. You put that in the microwave, heat that up.
And even have integrated circuits, the little miniature computer.
But we got a picture of that for number 5. We'll have the 3D graphs be brought up here in a second.
And with that, we were able to, at 1 inch levels up and down from the motor, we were able to create, and this is an example of the 4-inch levels that we actually recorded and constructed 3D wire mesh diagrams threw some color in there just to give it a little bit of more presence. But what you can see there in the upper left-hand panel, that's the magnetic flux data. And that shows the magnetic flux going in towards the motor, and the field as it wraps up and around the motor expands and goes back to normal. And it's the same thing with the fractional pieces of gravitational data that we were able to collect because the sensor actually had an accelerometer. So what this told us was that the fabric of space was literally being bent and affecting in a local capacity a change in the gravitational pull. Mm-hmm. And we were actually able to alter it. And that's what's so exciting about what we've been able to collect and demonstrate.
Well, we see it as exciting.
Well, we see it exciting. Most people would say, you know, like, so what? But what it really identifies is the fact that the fabric of space can be literally altered and compressed. And then once that field is in front of the craft, which Alcubierre had talked about, it then moves up and around on the back and expands back to normal. And so, again, that's what was very exciting about it. We also got results when we turned the motor off, it still moved. Now, I can verify there was 0 power going to that motor when you release the micro switch. Mm-hmm. There is no resident or any kind of residual power into the system. It cuts it off 100%.
Yeah, I think we had a graph on that too.
And with that said, we had experienced 1.5 to 2 seconds of additional movement of the motor. And so... And
then I was also wondering, what's that upper left one telling us? It was when the motor was turned off, you see a little influx of power.
Yes, when the power is turned off, there's about a 1 to 2 seconds worth of additional power being displayed there that we captured that shouldn't have been there.
Yeah, where's that come from?
And so there's a couple theories about that. It could have been electron puddling inside the motor itself because of our fractal panels that we utilize in the RF antenna section of the motor. But I don't believe so. I believe is that since we actually have demonstrated that we are affecting the fabric of space, that this is a residual of when you cut the power, the forward part of the motor is rebounding back to normal space. And we're seeing that flux because these sensors pick up energy. And that's exactly what you would expect to see if you did cut power to a motor like that. Mm-hmm. Now, you know, we're sitting here and we're talking about these experiments, 1.5 pounds. Our graphs show that once we get up to approximately 3,300 watts of power, that we would be able to lift about 15 pounds off the ground. Now everybody says, well, why don't you do it? Well,
yeah, why not?
It's extremely expensive all of our equipment is all custom. And until I'm satisfied as we incrementally build up power and test and make sure that there's not going to be any kind of distortions in the equipment, I can't afford to have anything smoke. In other words, you know, we're talking like $15,000 per unit to actually repair these things or build a new one if they totally fry.
So for $15,000, you can make yourself a space warp engine? That's what I'm taking away from
No, that's one portion of it. I mean, we have throttle controls, we have exciters, we have linear amplifiers, we have battery power supplies. This whole system works on battery. It's already been designed to be deployed to space. So that's the other interesting aspect of it. You don't need to plug this into the wall. We run off of batteries. We've been doing this for 2.5 years right now. But the real important aspect of the motor is being able to go from point A to B in space in a very short time frame. So even with our existing 1.5 pounds of pull, which is 6.26 newtons of force, we could get to Mars in 45 days with that motor, just as it sets right now. And why isn't everybody clamoring, knocking on the door? Well, somebody was talking before the show saying, they're out of a garage. So is an Apple, and so in a lot of other major Fortune 500 companies. It's just that my overhead is low. And why would I want to go rent someplace when I can invest the money into the equipment?
Yeah, you got an extra garage, room anyways. As long as the wife doesn't complain about it, you can take up as much space.
As long as she can park her car on the other side of the garage, everything is cool.
There you go.
Happy wife, happy life.
Happy wife, happy life. All right. Well, we're coming down to the end of the show here, so maybe we'll have you back and do another show, and
Part two, and the space-based economy.
Go on a little bit further.
That's what this revolutionizes: is a space-based economy, a never-ending economy where everybody can benefit, not just financially, but educational and skill-wise. And those would be some interesting aspects, because most people, whether they don't understand the functionality of the motor, they do understand the functionality of economy. And a space-based economy is trillions and trillions and trillions of dollars of economy in space. And one just has to sit back and think about that just for a bit, of precious materials that are beginning to get rare here, gold, silver, platinum, things of that nature, to the asteroid belt. Helium-3 for fusion reactors. All that stuff is on the moon, and it's all there for the taking, so to speak, or mining.
All right, well, we'll have to have you back. I want to thank all of our listeners for tuning in to Spooky Action at a Distance. My name's Kyle Finley, and follow us on Facebook, and stay tuned for more Spooky Action at a Distance.